All right, so guys, the degree is going to absolutely help us to determine if we're rising or if we're falling. Again, absolutely huge part of that. If it's odd, opposite direction. If it's even, same direction. Don't want to forget that. But that's not all the degree tells us. Degree is going to help us out with some other things too. The degree is going to help us to determine the maximum number of zeros. So as we discussed in section 2.1, quadratics, x squared, degree was 2 for all of our functions. How many zeros did we say we could have? Said that there were 3 options. Do you remember? You could have 0, you could have 1, or you could have 2. Is there any possible way that I could draw a parabola that has more than 2 zeros? No. No, that could never happen. Just like there's no possible way that we could draw a cubic function that has more than 3 zeros. Okay? The degree is going to tell you the maximum number of zeros. But please understand the way that that's written. It doesn't say that the degree tells you exactly how many zeros there are. It does, but it doesn't. It does tell us how many zeros, but not all zeros are real. There are some imaginary zeros that are out there. Okay? So that's why it was very possible. If you had a vertex that was above the x-axis and you had a parabola that was opening upward, it wasn't touching the x-axis. You had imaginary zeros. I mean, they're imaginary. So again, where do you plot those? You don't, because they're imaginary, right? Same story with the cubics, or with if you have something degree 7 or something like that. That doesn't automatically mean that you're going to have 7 zeros if the degree is 7, but that's the maximum. That's the max number of zeros. It's going to be equal to your degree. Okay. We could also determine the number of turns that your graph is going to take. Again, anytime we have a parabola, doesn't matter what type of parabola. If the degree is 2, is there any way that I could draw a parabola that turns more than once? If you have a curve that turns more than once, it's not a parabola. Like, meaning if this were to turn again, well, yeah, that just became cubic. That's how that works. If we have 2 turns, again, it's a different story, not the same type. So the number of turns, that's going to be determined based on your degree minus 1. So if you had, what did I say before, degree of 7, how many turns would we expect in that graph? Up to 6 turns, right? So again, please don't make that harder than it needs to be. Degree is going to tell you the end behavior. Degree is going to tell you how many potential zeros you have. Degree is going to tell you how many turns. Also, just as a reminder, we've been doing this all along, but when you want to find zeros of the function, you're going to set f of x equal to 0 and solve. So if we were to do that eventually here, before we do that, let's answer some questions. So what's the degree of this function? If I get my head out of the way. Ooh, the degree is 4, which is odd or even? That is even. Okay. So if we know that that's even, what are you going to tell me about the ends? Even degree, they're going to go same or opposite direction? Same direction. They're both up or they're both down. Based on the fact that the leading coefficient is negative, what do we know about the ends? Down. So the left, it's going to be falling. The right, what's that going to be doing? Also going to be falling. Okay, good to know. Good to know. You said the degree was 4, so what's the max number of zeros? How many turns? 3? Okay. Off to a good start. Now, to actually find the zeros, we're going to put a 0 in place for f of x. That's equal to negative 2x to the 4th plus 2x squared. Okay. So we want to factor the right side. Number of ways we could do this, but what do you think we should factor out on the right side? Negative 2x squared. That's going to leave me with positive x squared minus 1 in the interior. So, again, number of ways that we could play this out. I'm actually going to factor the negative 2x squared a little bit further. You good with me calling that negative 2x times x? Everybody good with that? Okay, and then we have less options as how we would factor out that dots, that difference of 2 squares. X plus 1 times x minus 1. Now, does everybody understand? I know that I'm getting a little ahead of myself. This is something we're going to revisit here in a couple more slides. But this x plus 1, that's not a 0. We understand that, right? Do we know what we call that? What the x plus 1 is? That's a factor. Okay, that is a factor. Factors lead to zeros, don't they? So x plus 1 is a factor. X minus 1 is a factor. X is a factor. Negative 2x is a factor. Those are all of my factors. This is I don't know if it's just for me or math teachers in general, but that's kind of like nails on a chalkboard type thing. that a lot of people inadvertently say, oh yeah, x plus 1 is my 0. No, it's not. It's not a 0, and that's a factor. It's something that up until this point, we've probably been perfectly fine, like interchanging those two terms, but we're kind of getting at that point to where we're going to start making mistakes if you're supposed to find the factor, but you find the zeros and things like that. So once we have these factors, I'm going to set each of these equal to 0, correct? So negative 2x equals 0. Solving that out, we get that x is equal to 0. 1 down. All right, next up, set the x equal to 0. There really isn't anything to solve. We've got it, x equals 0. Okay, x plus 1, my factor, set that equal to 0. What does x equal here? Negative 1. Finally, x minus 1 is equal to 0. Set that up, x equals positive 1. All right, now, we said a while ago the maximum number of zeros was 4. Did we find 4 zeros? Kind of. I'm actually going to strengthen that and say we absolutely found 4 zeros, but I could see how somebody might have this on an answer line of a test or something like that. What are your zeros? And you wrote negative 1, 0, 1. No need in writing 0 multiple times, right? But we better make note of that. Does that make sense? Graphically, there's a big difference between 0 showing up twice and negative 1 only showing up once. There's a big difference in how that's going to look. So, speaking of that graph, here's the deal. We have a 0 at negative 1, a 0 at 0, actually 2 zeros at 0, and a 0 at positive 1. You told me at the beginning of this problem, if I were to scroll back up, you told me that the left and the right ends were going to be going in the same direction, both going down, both falling. So that means if I know where my zeros are, I can already sketch this into where these are falling. Are we seeing how now we have some options? If I want to draw in the remainder of this graph, should I go through or should I turn, then go through, or should I go through, turn here? Again, what are we going to do? And everything hinges on this concept right here. 0 shows up twice. Negative 1 shows up once. 1 shows up once. This is that concept of multiplicity. This has a multiplicity of 2. So we're going to be getting to the point now. You and I know that you haven't done this before, but when we're listing out our zeros, we're going to write negative 1, 0, multiplicity of 2, and positive 1. So this is the way that we're going to write that out. When you have multiplicity of 2, what does that do for us graphically? That turns it into a bouncing or a turning point. Okay? Now, please don't get it mixed up. This is a common misconception. Very seldom do we have multiplicity of more than 2, but occasionally you have 3, even 4. Please don't think that if you show up more than once that it's a bouncing or a turning point. It's an odd or an even thing. If you have odd multiplicity, like this technically has multiplicity of 1, you're going to go directly through that point. If you have multiplicity that's even, in this case 2, it's a turning point, multiplicity of 1. So it's going to look roughly something like that. Now, do you suppose in the future we're going to actually care about finding these relative max points? Yes. We're not there right now, and that's okay. We don't need to figure that out, but are we feeling good about why we turned at 0, but we went through negative and positive 1? All right. So that's the idea of multiplicity. When you have odd multiplicity, you're going to cross through the axis. If you have even multiplicity, it's a turning or a bouncing point. Okay, so let's try that again. F of t, we're going to put a 0 in place for f of t. That equals t cubed minus 8t squared plus 16t. What can I factor out on the right side? T comes out. We have t squared minus 8t plus 16. We can factor a little bit further. Multiplies to 16, adds to negative 8. We've got t minus 4, t minus 4. So what are my zeros? Those are my factors. T minus 4, and t minus 4. These are my 3 factors. What are my zeros? T equals 0. T equals 4 with a multiplicity of 2. What does that mean for me on my graph? That means that we have, let's see, 1, 2, 3, 4. Means that we have a 0 here and we have a 0 there. Now, we didn't spend any time looking at the end behavior stuff. Degree was 3. That's odd, so we're going opposite directions. Lead coefficient is positive. What does that tell me about my left end? False. Right end? rises. So we're only saying that t equals 0 one time. So that means we're going through this point. T equals 4 with multiplicity of 2. So that is my turning point. Okay? Guys, how do we feel about this information? Okay, that's what the graph really looked like with the relative max in there. All right, so guys, I know that we touched on this because I knew that we'd be a little short on time, but again, we've already touched on this. There is a difference between zeros and factors. Why you gotta be weird, man? I don't know what's going on.
She said she was gonna fight me. No,
I,
you said you were gonna fight me.
I wouldn't do that.
No,
She's gonna mess you up. Guys, have a great weekend. We'll see you all on Wednesday.